Hello and welcome. In this tutorial, you're going to create a program in a circuit that measure your reaction time. So we're going to install an LED and a buzzer, and when either or both come on, you press the button and you measure how many hundredths of a second this reaction took. So first thing we're going to do is install the components onto the breadboard, and then we're going to build a counter. And then we're going to build a counter that gets interrupted with that button, which is effectively our circuit. So let's start with the button. Here we go. We grab one. So we're going to get a wire that goes into the red. We're going to need a resistor that goes into the GND. As I've said before, the value of the resistor doesn't matter very much in this case. Then finally, we get a wire to go into a digital pin. Now, I like 3 because we've just used it before. 1, 2, 3. So we're going to do that again. Next, we can set up a light. My favorite color so far has been red, so we're going to go with red again. Short leg in the minus, resistor in somewhere, 4, and finally a cable into the pin. Now, what pin did I draw here? 9. Let's go. LED can go into 9, 8, 9. And finally, a buzzer. Now, let's have a quick look at where the plus is. And to be honest, this would be better served by an always-on buzzer, but we're still going to solve the problem with the one that we've got. So I think this is going to be the short leg, and that's going to go into a GND. Can go right behind. There's a ground right there. And the plus is going to go into pin 12. So the plus is going to go right next to it, and then over. Oops. Right there and over onto pin 9, 10, 11, 12. So our first goal is going to be to write a program that essentially has a counter. Then we interrupt that counter with a button. Then we introduce the light and finally the buzzer. So counter, int counter. And it can be a counter for any distance, any length of time that we wish. So in the loop, I guess in the setup, we can use a serial dot.print. Now, serial.begin 9600. And here we can increment the counter. Counter equals to counter plus 1. And we can serial.print ln counter. So right now this will happen at an extremely high speed, and if we delay for a second, what you're going to see when we upload this, I will, for now, just save it as any random sketch. So you're going to see a counter that goes from 1, 2, 3, 4. So the reason it starts at 1 is that we increase it and then print it. So that's what the program does. Now, if we wanted to make it measure milliseconds, like thousandths of a second. Now, this whole thing up to here should have only taken 1 second. So one thing we've learned is print commands take time. So you definitely want to execute this only once in the eventual program. And we may not want to measure milliseconds. We can just do with hundredths of a second. So right now, we're going to try to interrupt this count, to try to make it count until the button is pressed. So I'm going to call it int button, that's pin 3, and we're going to have an input. Pin mode button is an input. And right here, we can make all this happen while analog read button double equals to low. Right. So once the button becomes high, and only when the button becomes high, we can then serial print the reaction time. So watch this. Serial print. I guess if I leave it there, it's just going to freeze. So this is going to be just a demonstration. If I leave it in there, the count should freeze when we press the button. Watch. It's gonna go. Uh-oh. That did not work. Okay. So while analog read button is low, let's see. That is in 5V, that is in GND. So buttons should be low by default. And when that's not the case, we can delay 5,000. So that's the while loop. That really should work. If it doesn't, well, why did I write analog read? It's digital read. Okay. Yeah, buttons either high or low. Analog read would have to be double equals to a value, 0, a less than 1 or something like that. So let's have a look at that. We should have flying numbers and a freeze when we press the button. And the freeze will only be for 5 seconds. The numbers are going to resume. Great. So we can now also say counter equals to 0. We can return to 0. So when it resumes, in a way, that's my reaction time. 34 hundredths of a second. And you can make this whole thing more accurate by moving the serial print outside of the count. So if the serial print happens there, except if we did that, we wouldn't know to press the button because the numbers are going. So at this point, we can add the LED. Int LED. LEDs are 9. And pin modes. So the LED is an output. That is very, very good. So we need to turn this LED on after some amount of time. And I guess that making that sort of time random would be really cool. So in the loop, we can say delay, and then I can say, well, since it's milliseconds, we can say random anywhere between 3 and 8 seconds. I think we need a second bracket. So after 3 to 8 seconds, the counter is going to start. Well, when the counter starts, or right before it, we can turn on the light. Digital right, LED, comma, high. And when we stop the counter, and I don't really think we're going to need this delay to be 5 seconds. Maybe just wait an extra 2 seconds here. Okay. This could work. Watching for the light. Then we're going to press 19 hundredths of a second. It's going to come on again, though. You can 19 again. Come on, I can be faster than 19. Ah! I'm getting slower. Oh. Come on. Yes. Okay. Took me a while, but there you have it. My reaction time is about 0.18 seconds. So of course we can improve on the display style. And in fact, I'm wondering whether we should do that first or create a buzzer beep first. I don't know. See, the buzzer beep is going to be a challenge because it may itself take time, and we can't really just do it on one line. I guess we can set tone, and then we're going to press it, and when we set tone, the buzzer is going to start working. I'm going to try that. I'm going to call it int buzzer 12. What am I doing? Equals to 12. So with the buzzer set there, right here after the LED, we can do tone, buzzer, and just, you know, a pretty good 1000. We'll go with that frequency. And after the 2000, we're going to go for the no tone buzzer. Okay. This should be interesting. Oh. Ooh. It is true. Human reaction time is better to sound, and that works beautifully. That works beautifully. I love it. So, yeah. The only problem is, so if you're having something annoying like that, you can always go File, New Sketch, and just upload a blank. Or you could have pulled out the cable for the buzzer, whichever. So all we need to do now to make this game perfect is improve the print statement. So where is it? Serial.print. Right there. So dot print, we can just say, hey, your time was, so print that. We can serial print the counter as well. And then you can even print counter divided by 100. Might work. And then serial.print space seconds. This would have to be print ln. So I don't know if this counter divided by 100 is going to produce a working decimal, or whether I have to create a variable, which is a floating point or a long. But I imagine it will be fine. Let's go. Ah! Your time was 0 seconds. Okay. So that division isn't working. I guess. Okay, this time I'm going to pull out a cable, which is this cable. Ah, stop it. Hundredths of a second. Done uploading. Moment of truth. Fourteen hundredths of a second. 20. I preempted that one. There you have it. Pretty good. I absolutely love it. I'm gonna keep on playing with it, and in the next tutorial I'm going to look at saving our results into an array and then printing sort of a longer set of results. So what if we had, I don't know, 4 trials of 10 attempts, and if we could print out those? Because that gets into arrays and data management, and as we advance in our usage of Arduino, what we're going to want to do is take sensor data and save it onto our computer or a device. And the first step towards that is organizing that data into arrays. So make this, enjoy it, have fun with it, and see you in the next tutorial.